For Jonas's science fair experiment, he builds and launches a rocket that lands on a raised platform. The path of the rocket can be described using a quadratic equation. The rocket reaches a max height of 81 feet. Use the diagram below to determine the height of the platform and how far from Jonas the rocket reaches its max height. Okay, there's a lot of information here. Let's take a look at this diagram. We have a parabola that represents the path of the rocket. So Jonas is going to launch the rocket from down here. The rocket's going to fly up. And it's going to land on this platform. The problem told us that the max height was 81 feet, and that's what we have marked right here. Since we're talking about a parabola, that max height occurs at the vertex. Additionally, we have this launch position. We can think of that as the root of the parabola. The question's asking us two things. First, what is the height of our platform? And second, how far from Jonas does the rocket reach its max height? So our rocket reaches its max height right here. That's the x-coordinate. So we want to find this distance. And again, this is a lot of information, so let's take it one step at a time. First, we want to find the height of the platform. And we're dealing with a quadratic equation, but we don't have the equation. So let's start off with the general form. So in general, y equals ax squared plus bx plus c. So we're being asked about a quadratic equation, so our first step needs to be figure out the quadratic equation, which means figure out these coefficients. And how can we do that? Well, we're given some points on the parabola, and we know that every point on the parabola has to make our equation true. So we can plug in those x and y values, and then we'll just have a, b, and c. And then we can try to solve for them. So let's try plugging in this point up here, 0, 72. So our y value is 72, and then our x value is 0. Anything multiplied by 0 becomes 0, so this part disappears, and so does this part. So we're left with our c equals 72. So we just found one of our letters. And now our equation looks like y equals ax squared plus bx plus 72. We're going to repeat this process with our other 2 points, and that should help us find a and b. Let's take that to the next page. So our quadratic equation currently looks like this, and we have 2 points left on our parabola. So let's start off plugging in our first point. So our y value is 32, and our x value is -4. -4 squared gives us 16. B times -4 gives us -4b. And cleaning this up, we have 16a minus 4b plus 72. Let's subtract this 72 from both sides. We'll get our variables by themselves. 32 minus 72, that's -40. And we have 16a minus 4b. Right now, we can't figure out what a and b are. However, if we do the same process with our second point, we'll get a system of equations. Plugging in our second point, for y we have 77, and for x we have 5. 5 squared is 25. So we'll write this as 25a plus 5b plus 72. And again, let's get our a and b by themselves. We get 5 equals 25a plus 5b. In the past, when we looked at systems of equations, we usually had x and y. In this case, we have a and b, different letters, but it's the same process. So let's line up our two equations and see what we can do. So our first equation here, I'll write as 16a minus 4b equals negative 40. And I'll bring the second one down. We have 25a plus 5b equals 5. Writing it this way lines up our variables, and with systems of equations, we have two options, substitution or combining, and these equations are set up for combining. We have our variables lined up, and before we combine, there's actually something we can do to make this simpler. Each of these numbers is divisible by 4, so we can factor out of 4 and make those numbers smaller. So now, if we factor out of 4, this becomes 4 times 4a minus b. We're essentially dividing out of 4, so if you multiply that 4 back in, you would get the original expression. And same on the other side, we can write this as 4 times negative 10. So if we divide both sides by 4, then we would cancel out those 4's. So now our equation looks simpler. And we can do the same with the second equation. Each of our numbers there is divisible by 5, so we'll divide out of 5, meaning we'll factor out that 5 first. So we're left with 5a plus b on the inside, and then 5 is the same as 5 times 1. So dividing by 5, we'd cancel those out. So our new system looks like 4a minus b equals negative 10, and 5a plus b equals 1. And now this is easy to combine. We just need to add up the pieces on the left side, and then our b's would cancel. So let's do that. Add up the pieces on the left and the right. 4a plus 5a gives us 9a. Our b's cancel. And on the other side, we have negative 10 plus 1 is negative 9. Divide both sides by 9, and we get a equals negative 1. So now we just need to substitute that back in to one of our equations. Let's take our first one. So we have 4 times a, which is negative 1, minus b equals negative 10. 4 times negative 1 is negative 4. And we want to get b by itself, so let's add 4 to both sides. We get negative b equals, and negative 10 plus 4 is negative 6. If we multiply both sides by negative 1, those negatives disappear, so we get b equals 6. So we figured out our two coefficients, negative 1 and 6. So the quadratic equation we had looked like this, and we just figured out a is negative 1 and b is 6. So we can write our equation as y equals negative x squared plus 6x plus 72. So this was just the first step. Our problem deals with a quadratic equation, and we had to figure out what it was before we can answer anything else. So what was our first question? Our first question was, what is the height of the platform? Our platform is at x equals 8. So all we need to do is plug in x equals 8 into our quadratic equation, and we'll find the y value, which is the height. So our platform at x equals 8, we just need to figure out our y, so we just plug it in. We'd get negative 8 squared plus 6 times 8 plus 72. So negative 8 squared, when we have a negative in front, we think of this as negative 1 times 8 squared. So our order of operation says to do the exponent first. So we get negative 1 times 64, which is negative 64. If it said negative 8 squared, that's negative 8 times negative 8, which would be 64. So you have to be careful with which of these we're talking about. And then 6 times 8 is 48. Negative 64 plus 48, that gives us negative 16. And then negative 16 plus 72, that's the same as 72 minus 16. That gives us 56. So our platform is 56 feet high. So that was our first question, the height of the platform. We just found that it's 56 feet high. Next, we need to figure out this distance. The distance from Jonas at the launch to where the rocket reaches its max height. So the rocket reaches its max height up here at the vertex. And so the x value is down here. So we just have to find that distance. Okay, so we need to figure out two things. We need to figure out where is Jonas, so where is this root, and what is the x value for our vertex. So let's take it one step at a time. We're going to start by finding the root that tells us where Jonas is. So we have our quadratic equation from before, and we need to find the roots, and specifically the root where Jonas is at. The roots occur where y equals 0, and to solve for x, we need to factor or use the quadratic formula. Let's go ahead and factor this. Let's start off by factoring out a negative 1. So we'll get x squared minus 6x minus 72. And if we divide both sides by negative 1, then that negative disappears. We get 0 equals x squared minus 6x minus 72. And now that we don't have a negative here, it's easier to factor. Our first term is going to be an x. X times x gives us our x squared. And we need two numbers that multiply to negative 72 and add up to negative 6. So if you know your multiplication facts, you should know that 12 times 6 gives you 72. And we need one of them to be negative so that they add up to negative 6. So we get x minus 12 times x plus 6. And this is still equal to 0. And we're multiplying two numbers here, and we get 0. So either the first one is 0, or the second one is 0. So we get x equals 12, or x equals negative 6. So we just found the roots, so let's add these two to our picture. So we have 12 and negative 6. So our root over here must be negative 6. And where do we put 12? Well, 12's not actually on this picture. Our parabola stops up here, where the rocket lands. However, if the rocket had kept going to the ground, it would have hit x equals 12. So now we're closer to the answer. We want to figure out this distance here. And we just figured out that Jonas is at -6. That means he has to walk 6 steps to get to the center. And now we need to figure out this portion here. As we mentioned before, our point here is the x-coordinate of the vertex. And we have a formula for finding the x-coordinate of a vertex. Our x-coordinate is -b over 2a. And what was our quadratic equation again? We had y equals -x squared plus 6x plus 72. So our a, our coefficient there, is -1, and our b is 6. So plugging that in, we get -6 over 2 times -1. That gives us -6 over -2, which is a +3. So the x-coordinate of our vertex is 3. That's where our rocket reaches its highest point. So x equals 3 means once Jonas walks to the center, he just has to walk 3 more steps. So overall, Jonas is 9 steps away. So we can say the rocket reaches its max height 9 feet from Jonas.